All right, good morning, everybody. We are going to do our second lesson for today within our new fractions unit. If you were to follow the textbook, you would see that the textbook does things a little bit differently than what I like to do. The textbook goes on to talk about adding and subtracting fractions. I really don't love going there right away because I think that there is a little more of a complex thought process in it. So what I'd like to do is I'd like to actually get us to look at today we're going to actually multiply fractions. And I find that multiplying fractions and dividing fractions is a little bit more straightforward. So let's just quickly talk about multiplying fractions. The reason I say that I think it's really way more straightforward and way easier to understand is that the act of multiplying is a little bit easier. But before we do that, I just want to remind you that whenever it says of something, it means that we're multiplying. So something that you need to remember is that when you're looking at word problems or anything like that, if it says of, 1/4 of something else, you're looking at multiplying. So for those people who are visual learners, let's say that I got the question, let's say 3/4 of 2/3. And I was asked to visually represent this. You always draw the second fraction, the one after the of, first. So let's say that I have this idea of it's 2/3. So what I need to draw is I need to draw a square, and I'm going to break it into thirds. So 1, 2, and 3. Okay, only 2/3 of this square, right? It says 2/3. Only 2/3 of the square are going to get colored in. So I'm just going to represent it this way so we can have a visual. So this is step 1 done. Now, it's 3/4 that I need to figure out. So what's 3/4 of 2/3? So what I'm actually going to do is I'm going to then go the opposite way. So if I drew vertical lines on this one, I'm going to go opposite way. So I'm looking at the denominator, and the denominator says that I need to split this box into fourths. So I'm going to do that. 1, 2, 3, and 4. Okay. 3/4 of the boxes need to be colored in. Now, 3/4 of the already colored in boxes is what I'm looking for. So I'm going to color this one in. 1, right? 2, and 3, right? 3/4, right? Here's 1, here's 1/4, here's 1/4, here's 1/4, here's 1/4, here's 1/3, here's 1/3, and here's 1/3. So of the colored boxes that were 1/3, I colored in 3/4 of the next one. So now what I'm looking at is only the boxes that have 2 colors in them. Okay, so the first thing I'm going to do is I'm going to count up all the boxes that are in this now square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 now becomes my denominator, right? There are 12 total squares in this. How many are colored in both colors? Well, 1, 2, 3, 4, 5, 6. 6 of those are colored in both colors. Well, I know I can reduce this. 6 goes into 6 once. 6 goes into 12 twice. So half of the squares are colored in. Now that makes sense because I've got 1, 2, 3, 4, 5, 6 that aren't colored in. Okay, so again, just a visual way of looking at it. I'm going to erase this really quickly. You can obviously go back and scroll back in the video if you want to look at it again. But I want to just show you again kind of what we're thinking about when we're looking at multiplication. Because one of the things I know that they will do in high school next year when looking at fractions, they will expect you to be able to explain it with a visual. So if you don't understand it right away, that's okay. We'll go back to it again, and you can always message me and I can help you out. So let's say that I did maybe an easier one this time. we'll do 1/2 of 1/3. So I look at my fraction after and I look at the denominator. It says third. So I know I'm going to be drawing a box. And I'm going to go vertically. So it doesn't matter. You can go horizontally or vertically. I'm going to go vertically and I'm going to split this box into thirds. It doesn't matter if it's perfect. Now, one of these thirds, so this is 1/3, 1/3, and 1/3. One of these thirds I'm going to color in. Okay. Now I go to the second one and I say, okay, the second part is asking me to do 1/2. So that means that this box, I need to split it in 1/2 horizontally. So I'm going to do that. And then I'm going to take a different color, and 1/2 of the already colored boxes I have to color in, right? Because I'm not doing 2/2, I'm only doing 1/2. So at this point, I ask myself, okay, how many boxes are there in total now? 1, 2, 3, 4, 5, 6. There's 6 total squares. How many are colored in? Double colored? Well, only 1. So that means that 1/6. So 1/2 of 1/3 is 1/6. So again, I'm showing this to you because sometimes visual people need to see it that way. I know for me, it confused me the first couple of times that I learned it. So you can kind of use your own way, but I just wanted to show you this as an example. Okay, so let's get started with talking about how to multiply fractions. So when multiplying fractions, oh, this is not, remind me not to use that green again, it looks like. Jeez. When multiplying fractions, what we're going to be doing is the following. In your fraction, something times something, your denominators, all you're doing is you're multiplying one denominator by the other denominator to get the new denominator, okay? And then your numerators, you're multiplying one numerator by the other numerator and to find the new numerator. That's all it is. It's that simple, and that's why I really like going to it. So if we went with the first example, if I asked you what 3/5 times 2/3 was, well, based on what we just saw up here, I'm going to go across. So I'm going to go horizontally. So 3 times 2, that's 6. 5 times 3 is 15. Now, I could get this answer and be like, oh, okay, I'm done. Now, if you give that in any classes, you're going to get half marks because you can simplify your fractions. We talked about it in the last class on the TikTok. You have to simplify. So you ask yourself, what number goes into both? And usually the rule of thumb is you can start with 2, unless you can identify things like a 0 or a 5, and you know that you can divide by 5. Usually people start with a 2 and they see if it can go into both the numerator and the denominator. So 2 can go into 6, but it can't go into 15. So I go up 3. Yep, 3 can go into 6, and 3 can go into 15. So 6 divided by 3 and 15 divided by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. So 3/5 times 2/3 is 2/5. Okay, when you boil it down to it. Okay, let's continue on. We'll do a couple more, and then I'll get you guys to try your own. Let's do. There we just had proper fractions. Let's do one where we have improper fractions. So let's say that we have 5/4 multiplied by 11/10. Okay, so all I'm going to do is I'm literally going to go across with those numbers. So I'm going to say 5 times 11 is 55. And 4 times 10 is 40. Now again, I could say, I'm happy with this answer, but I know that numbers can go into it because I see a 5 and a 0. I know 5 can go into it. So 5 goes into 5 goes into 55. It goes 11 times. And 5 goes into 40 8 times. Now, on most quizzes, it will say whether or not to leave it in improper fraction or not. If it says leave it in improper fraction, you're done right now. But for our own sake, we're going to actually change it into a mixed number. So I asked myself, how many times does 8 go into 11? Well, it goes once. And 11 minus 8 is 3, so that's the remainder. And then I keep my denominator. So what I did again was I asked myself, how many times does 8 go into 11? It goes once. So I'm going to take 8 away from this number, and it's left me with 3. So that 3 becomes the numerator, and the 8 transfers over. Okay, so we've done a proper fraction, an improper fraction. Let's do another improper fraction. This one where there's a mixed one. So in the sense of not mixed number, but you have one proper fraction and one mixed proper fraction. So I'm going to do 7/3 times 7/8. Okay, so again, let's do our math. We just go straight across. 7 times 7 is 49. 3 times 8 is 24. I can't reduce either of these, right? Because no number will go into these equally. So I'm going to ask myself, I got to turn it into a mixed number fraction. So I've got my improper fraction. I need to turn it into a mixed number. How many times does 24 go into 49? 24, 48. So 2. 48. So if I take 48 away from 49, I'm left with 1 and 1/24. So 7/3 times 7/8 is 2 and 1/24. The last one we're going to try is a mixed number fraction. So when we have two mixed number fractions, and so for this case, we're going to do 3 3/4 times 2 1/5. So again, very basic knowledge stuff right now. What do you think a lot of people make a mistake of doing? Yeah, that's right. They take this number and this whole number and they multiply them, and then they do the fractions separately. And I'm going to show you in a second why we can't do that. So in this case, we need to do what first? We need to turn them into improper fractions. So like we talked about in the last class, 3 times 4 is, so we multiply it this way. 3 times 4 is 12. 12 plus 3 is 15, and we keep the denominator. So 15 times 4. 5 times 2 is 10, plus 1 is 11/5. And now we'll just do the math. 15 times 11 is 165/20. Well, I know that I can reduce by 5s, right? So 165 divided by 5 is 33. 20 divided by 5 is 4. Can't do anything, right? Can't reduce this. So I'm going to turn it into a mixed number fraction. 4 goes into 33 how many times? Or 33 divided by 4 will give me 8. 8 times 4 is, and this is the thought process you're doing. Once you figure out how many times it goes in there, you take your whole number and you multiply it by the denominator to figure out what's your total right now. So 8 times 4 is 32. 33 minus 32 is 1, and keep my denominator. So a quick understanding of the 3 different types of ways of doing multiplication. I'd like you to try your own, so I'm going to get you a new board. And I'd like you to try the following for me. The first one I'd like you to do is 7/10 times 3/4. The next one I'd like you to do is 6/2 times 3/5. And the last one I'd like you to do is 7 3/8 times 2 4/5. Okay, so pause the video here, please, and come back in a second to see how you did. Okay, so you're back. So let's see how you guys did on this activity. So question number 1 was, 7/10 times 3/4. We just do straight multiplication here. 3 times 7 is 21. 4 times 10 is 40. Can any numbers be reduced? Nope, so 21/40 is our answer. Excellent job. The next one is a improper fraction times a proper fraction. So 6/2, again, we're going straight across. 6 times 3 is 18. 2 times 5 is 10. We're left with an improper fraction. We're going to change it into a proper fraction, but first we could actually reduce this. to make it a little bit easier for ourselves, or we can go right away. So you could either say, okay, I know that 2 goes into both of these. 2 goes into 18, 2 divided by 18 divided by 2 is 9, and 10 divided by 2 is 5. So I can either go that way, or I can go right away to solving it like this. How many times does 10 go into 18? Well, it goes into 18 once, and I have 8 over 10 left over. Now, the reason I say to go this way first instead of going this way is because either way, I'm gonna have another step, right? If I go this way, I still gotta turn it into a mixed number. If I go this way, I can't leave it like this because 8 and 10 are still divisible. So now it actually becomes 1. 8 divided by 2 is 4. And 10 divided by 2 is 5. Well, I could have gotten that a lot quicker if I had just gone this way, because I would have asked myself, how many times does 5 go into 9? Well, it goes once, and I've got 4 remainder over 5. So just something to think about as well. The last one, let's turn these into improper fractions first. 8 times 7 is 56. 56 plus 3 is 59 over 8. Times 5 times 2 is 10. Plus 4 is 14 over 5. We get 59 times 14 is 826. 8 times 5 is 40. We can see even numbers here, so we know that it's going to be divisible by 2. So we divide it, we get 413 divided by 40. Sorry, divided by 20, because we're dividing each by 2. We know that this number is not going to be able to be found, so we have no way of dividing it further. So let's turn into a mixed number. 20 goes into 413. Well, 20 times 20 is 400, so 20 times. And what do we have left over? We have 13/20 left over. Okay, so that is very simply the knowledge base of it. There is one thing I want to show you, because some of you might have learned it already in your math classes or with a tutor, an easier way of doing multiplication, and that's the cancel out method. And what the cancel out method looks at is finding a way to pre-simplify your multiplication equations. So for instance, let's say I had 5 over 6. Oops, this marker's on its last leg. 5 over 6. Okay, we're going to use a different marker. Sorry, guys. Let's say we had 5 over 6. And we were multiplying it by 7 over 10. I want to look to see if across from each other or on top of each other have any common factors. So in this case, what I'm trying to say is this. I look at 5 and I see 10 on the bottom here. I know that 5 can go into 5 and 5 can go into 10. So what I can do is I can actually cancel these out pre-multiplication. So I know that 5 goes into 5. Well, this is now just going to become a 1. Okay? And 5 goes into 10 twice. That becomes a 2. And now I can say, okay, I know 2 and 6 share, but they can't because they're on the same level, right? They're either above ground or below ground. You can only share with somebody who's the opposite area of you. So if you're above ground, you can only share with a below ground person. If you're below ground, you can only share with a above ground person. So there's no more opportunities to cancel out. So what now I can do is just the simple math, right? Now I'm dealing with a 1, right? 1 times 7 is 7. 6 times 2 is 12. Can't simplify that anymore, so that's the answer. And just to show you that the cancel out method is it's fine to do, if I were to just do the question itself all over again, 5 times 7 is 35. 6 times 10 is 60. I can divide both of these by 5. So divide this by 5 and this by 5. So 35 divided by 5 is 7. 60 divided by 5 is 12. It's the exact same answer, but I actually did a little bit of work ahead of time to help me out. Let's try another one together. So let's say that I had 2/6. You know what, we'll do this one. 3/8 times 4/9. So I look and I see, do I have any ones that are sharing common factors? Well, in this case I do, right? I see 3 and 9. Those both share a common factor of 3. So 3 goes into 3 once, 3 goes into 9 3 times. Oh, I also see that this one and this one also share, right? 4 goes into 4 once, and 4 goes into 8 twice. So now I'm left with a much simpler equation to multiply, or a fraction to multiply. 1 times 1 is 1. 2 times 3 is 6. So 3/8 times 4/9 is 1/6. The last one I'm going to show you is still a cancel out method. And this one's one where you're kind of going to do multi-step. You can actually reduce and cancel out as many times as you need to. And this one was going to be a good example of what I mean by that. So let's start off with this. I see 15 and 45. I know 15 goes into both 15 and 45. So I'm going to cross this one out. 15 is going to become a 1. 45 is going to become a 3. What else do I see? Oh, I see 30 and 26 are both even numbers. So I'm going to divide them by 2. So I'm going to get 15 up here, and I'm going to get 13 down here. And I'm looking, and I see this. I see a 15 and a 3. And I know that 15 and 3 both share a common factor. So this 3 now, 3 goes into 3, it's going to become a 1 now. And this 15 is going to become, 15 divided by 3 is 5. So now I've done an extra step, and that's fine. And you can do that as many times as you need to in order to cancel it out. I look around, nothing else. So now I just multiply. 5 times 1 is 5. 1 times 13 is 13. The key here is making sure that if you are going to do a cancel out method, I would recommend using a different color, because then you can kind of identify which number. I've also seen people who circle the numbers once they've reduced it to the lowest amount, because they don't want to get confused with maybe if they've done it twice. Okay, so that's the knowledge section for today. We're going to go on to the application questions with some examples. Okay, thanks.